isn't it? Dang. Oh, dang.
So,
Who says it?
y equals integral of 1 over x dx. You get ready to integrate this. I know how to do this. I can do this in my sleep. The integral of 1 over x dx is integral of -1 dx. And so I raise its power by 1. Divide by the power I get, plus c. And that's a problem. Why is this a problem?
Because you can't do that.
It's undefined. And we might think, well, that's okay. Maybe it is undefined. I can live with that. What does 1 over x look like? Hey, ladies, have that discussion some other time. It's awesome. I have x, 1 over x. What does that look like, Laurel? No, that's what the derivative looks like. What does the function itself look like? There's a whole chapter in Algebra 2 where it made you draw a bunch of these. They should have still done it wherever you took Algebra 2. Is there area, Laurel, between here and here? Well, then there has to be a number. And I got undefined, and that's not cool. I need a better way to do this. So there's a couple things. Let's talk first about why it's undefined. If I start at 0, what happens to me? At 0, it's undefined. It's at infinity. And yet every integral we've thus far done starts at 0. And that's a problem because I can't define this one. And that makes me want to cry. So we're going to come up with a way to define this one. So the next step we're going to use is we're going to try this trick we just got good at. And that is specifically you are going to draw a slope field for, now if we're integrating this would be the derivative of the function, right? This dy dx would be 1 over x, agreed? So let's find what a slope field would look like for that, and let's see if we can figure out what the function is. Let's guess what the answer is based on looking at the picture. Let's do it for realsies this time. It's like that. The function looks like this. This looks like a log of some sort. Log base something.
Log base E. Log base natural.
So, somewhere about the 1800s, a bunch of mathematicians got together and tried to figure out log base what?
10.
And like half of them knew what the answer was, but spent the next 10 years of their lives proving it. And it's log base E, or ln, which you guys have looked at the bottom of the page now know. So one of the fascinating developments, and one of our first, what we call existential function, is that the integral of 1 over x dx is in fact ln of x. Plus c. That's why you guys forget the plus c. Hold it right there. That means that, by the way, as a circumstance of that, the derivative with respect to x of ln of x has to be what? 1 over x.
Oh.
Has to be. And is. And in fact is. So I gave you some problems on the bottom to play with. Here we got integral of 1 over x dx. I got negative 1 over x dx from 1 to 2. Oh, I forgot. We forgot something. I totally forgot something. I was up here, guys. Totally forgot something important. Really important. We saw the right-hand side was 1, right? What's happening on the left-hand side? There was another function over there on the left-hand side. What was that? It went to the right. That's ln of x. Why does it have a mirror image on the other side? It's the absolute value, and I dropped the absolute value, which is almost criminal. So please put that in now before I totally forget that. So it's the absolute value. So it's ln of the absolute value of x plus c. So therefore, the derivative of ln of x is still 1 over x, because that would be a positive value, or negative value still gives you 1 over x. Good?
Yeah.
Try 1, 2, 3, and 4. A, B, C, and D. My bad. Try A, B, C, and D. Okay. What's the purpose of doing a slope field? It's to look at the original equation, right? So what we're doing is we're saying if I draw all the slopes, where they go. Now this next one over here, what would I do? I'm taking the derivative. The derivative therefore is 1 over x, so it's going to be 1 over 2x. Guys, I'm going to do something really extraordinarily weird in a second. 1 over 2x times the chain, which is 2. So I get 1 over x, agreed.
How do you get 1 over 2x?
Well, because it's 1 over x normally, but I'm taking respect to u instead. So I take the derivative of the outside like I normally would, times the derivative of the inside, which is 2. Okay, I'm going to back up and do a u substitution because that clearly didn't work.
Yeah.
No, I guess it changed more. I just saw it.
No, you didn't. U equals 2x. Therefore, ln of u, the derivative of ln of u with respect to u, times the derivative with respect to x of 2x, agreed? So this becomes 1 over u times 2. U is 2x, so 1 over 2x times 2, which equals 1 over x. Now, that's not the way I'm going to do the problem. That's not the way I'm going to do the problem. Instead, what I'm going to do, wait, maybe not. Here's how I'm going to do the problem, because you guys know how to do logs. Listen. Golly! Third time I say listen, your voice goes down, not up. I know you can't hear me. Here's the way you do the problem the short way, because you know how to do logs, and maybe you don't. Multiplication inside is addition outside. So this is the derivative with respect to x of ln of 2 plus the derivative with respect to x of ln of x. Agreed? That's just a number, right? Gone. Derivative of ln of x is 1 over x.
So you just
Okay? All right. For homework, you have a weird set of assignments to do on the back, but I want you to try them out. Try the problems on the back, all of them. When it says sketch a graph, feel free to use your calculator. I want you to see these graphs. So draw them.
What is the command for 3 and 5?
3 and 5 is what are they?
What are they?
Yeah, solve.
Okay.
ln of 4 estimate would be even better. See you on Monday. We're going to cover some ground.